Hello, here we go. Let's solve this problem here. So we have this box, right? And it says a closed box. So the square base is to have a volume of 16,000 cubic centimeters. It says the material for the top of the box costs $3 per square centimeter, while the material for the side of it costs $1.50 per square centimeter. I'm going to find the dimensions of this box that will give us the minimum cost. Okay, so here we go. First, I have to draw a picture, and I hope that you have to draw a picture too. Why not, right? It'll help us out. We can label things so that we can identify quantities that we're talking about. Just makes life a lot easier, and after all, why not? It's good to make life a little easier. Okay, so it's a square base, so I'm going to make these two x's. That's what it means that you've got this thing here. And I'll make this into a y. Because there are three dimensions that we need, x, and y. And the first sentence tells us the following equation. Right? See, that's what we're really doing is we're translating this, these words into mathematics, literally. So this is the fact that the volume of that is 1,600. And this picture and all that encompasses everything about the fact that it's a square base. So let's write down the idea here that the cost, right, of making this thing, it says it's a $1.50. Let's see. The sides cost $1.50 and the top and the bottom cost $3. Okay, so $3, there's two of those. So let's say, so $3 times x squared, that would be the cost of the bottom. Now there's two of those, right? So we have to multiply that by 2 plus, and then we have 4 sides, and each of those are cost $1.50 per cubic centimeter. And how many cubic centimeters are there? There's y times x of them on each side, right? So there's 4 of these sides, and each one of those has area x times y. So you multiply that by the cost, and by 4 you get this expression. Now we know that we cannot minimize this cost function if it's a function of 2 variables. So we have to solve this equation here for one of the unknowns, and I think it makes sense to do this. Okay, and then I divide that by x. X squared. Okay, so let's do it. Now let's substitute that in there and see what our cost function is. So that our cost as now a function of x is equal to 6x squared plus 6. Now then we get times x times, now for y I'm just going to plug in this 16,000 divided by x squared. Okay, so then the cost as a function of x is 6x squared plus, I'm just going to leave the 6 there. 6, then we get 1,600 divided by just x. Okay, there we go. Okay, so now let's go ahead and differentiate this, because when we're trying to minimize something, we need to find its derivative and set it equal to 0. That's the major point in this section, this chapter, in fact. So I find the derivative, which is 12x squared. And now if I find the derivative of this business, it's a negative 6. Then we get 1,600 or 16,000 divided by x squared. Okay. Now I want to solve this, find out when this is 0, so I write down the equation. So when is 0 equal to 12x squared minus 6 times 16,000 divided by x squared? And now, to solve this, what we do is first let's kill the denominators. The way you do that is you multiply both sides of this equation by x squared, leading to the equation 0. is equal to, oops, hold on here. The hell? Sorry. What did I do here? I just noticed I made a mistake. Can you see it? Well, I can. When I differentiated 6x squared, I didn't change my exponent. It's a 1. So really, how we normally write that is that's not, there is no, right? It's a 1 there, but we just don't put anything normally. So that looks better. Okay. All right. So then what do we get here? So we get 12x cubed minus 6 times 1600. Okay. And now let's see, if I want to solve this, I'm going to solve for x cubed. So what I'm going to do is I'm going to subtract 12x cubed from both sides, of course. Then I get a new equation. Okay. Whoa, I hit a button. Okay. Okay, then I'm going to divide both sides of this equation by a negative 12. By negative 12, which leads us to the expression x cubed is equal to, let's see. All right, now, if I divide by negative 12, it makes it positive. 6 divided by 12 is 1/2, which means half of that 16,000 is 8,000. Okay, all right, now let's see what we get here. So what cubed equals 8,000? Well, this is a little bit ridiculous, but this is how I look at it. So 8,000, what is that? That's like 2 cubed, right, times 10 cubed. Okay, so that's 20 cubed, right? Okay, good. So that means that x is actually equal to 20. Okay? Because we know x is positive, because we're building a box, right? And so x is 20. So x is 20. Now let's go back in here and find out what is the cost. So if I take 20 and if I substitute it in here for this cost, that's what I would get. That would be my minimum cost. Okay, so that the answer would be, well, here you take 6 times 20 squared plus 6 times this quantity divided by 20. And this right here, and I'm circling right now, that would be our minimum cost of building this box. So, okay, I hope this helps you out. Thank you very much.